And my topic is on towards large reasoning model as a judge. And I'm Nuo Chen, a PhD student from NUS School of Computing. And here is my website and email, GitHub, and Hugging Face. And if you are interested on the related topic, please email me and feel free to chat any of your idea. And I also want to share about one of my recent work, because these days there's a lot of submission to the conference. So in this paper, we diagnose the crisis of the current AI conference model and reach the conclusions that the AI conference model is now unsustainable. And in the Reddit machine learning, and it reaches about 100,000 reads within 20 hours. So I think it is a really hot topic. And if you are interested about like LLM as judge, LLM as a researcher, and the AI conference model, please feel free to chat with me. And I will start from the very beginning of the background and the motivation of this paper, because I know maybe there is some audience are interested with this topic, but not really familiar with the LRM or LRM. So I will start with the reasoning part. And here is an analogy from OpenAI. And when they introduced about the OpenAI 01, they give this analogy. Like if we imagine the whole world problem space into this ball or into this circle, there includes a lot of domain in this ball. Yeah. And each piece is a domain, like in math, computer, or game theory. And in the center of the ball, it includes a lot of easy problems, for example, 1 + 1. And in the middle of the ball, it includes something like this problem, and it is maybe high school or even higher problem. And for the outer circles, it includes so many huge, really hard problems for humans to spend years to solve. For example, in math, it includes like programming hypotheses. So currently, LLMs are being developed to solve those harder problems. And also, there is a lot of method to benchmark the LLM's ability to solve the problems. For example, currently in the middle circle includes like mathematics, logic, and code. There is a lot of benchmark. But the currently LLM have developed so fast, and it can solve some problems that human experts think years to answer. For example, a data set called the Humanities Last Exam, it judges the LLM's performance or abilities from the PhD level or even higher level of the knowledge. So currently LLMs are benchmarking and generating for those even harder problems. And let we turn this ball to the left and think about the thinking time on the right. And we can find that for those easy problems, we just use the ability of the fast thinking. For example, when we ask 1 + 1 = 2, we don't need to think a lot of time. We can ask without any hesitation. But for those harder problems, we need to rely on the slow thinking. And it includes some ability of human thinking, like launching reasoning, for example, like verification, sub-goal getting, reflection. So to answer those harder problems, we will need the longer thinking process. And here is the LLM, and it is a method used by OpenAI 01 and DeepSeek R1, and they found that the large reasoning model can solve those like launching reasoning and make the LLM can ask questions. So this is the contribution of OpenAI 01 and DeepSeek R1. So there is a lot of work to following them to train an LLM. But the currently LLM's knowledge is limited by the math content of the current LLM. And also, let me introduce the background of LLM as a judge. Because like in 2020 or 2021, at that time we don't have the LLM research. So at that time we just judge 2 AI answers by a human. But for like in 2023, the researchers found that the LLM can be have the enough knowledge and enough understanding of the world to be a judge, and it can judge a lot of domain answers from the two AI. So it uses LLM to evaluate contents generated by themselves. And the process is that first we need to define criteria, or even we can skip this process to judge like one specific domain of LLMs, and also prompt LLM finally to generate the output of two AI scores. If like the score is from 1 to 10, like the first one score is 3, and the second AI score is 7, and finally give the feedback of the why it gives 2 scores. So it is the LLM as a judge, and let we give the analogy of LLM as a judge into the subspace of the problem, and it is the subspace of the previous space. It is the open-ended judge problem subspace, and we can find that there is also a lot of domain in this space, and they are like common people say, well, they will search or ask about like office productivity, like entertainment media, and etc. So it also includes the easy to hard problems. For example, for those easy judge problems, it includes the pairwise answers. For example, the A1 and A2 is both really cannot answer the question, so it is easy to judge, and they are both not correct. And also like the A1 is exactly correct, and A2 speak nonsense. So it is also a really easy judge problem. But for those harder problems, they maybe includes really long like reasoning chain or like a proof or etc. So and they are a bit different. Like they just differ by a few tokens. So it is also for human to judge which one is better. So it is the harder problem of the judge problem subspace. So because of the LLM development, so we also need to care about the LLM's judge on the harder problems. For example, in math writing, and also for like ambiguous alignment. In writing, it is a problem for our researchers that both the PhD and the professor will care about 2 versions of a paper and which one is better. So it is a really open-ended domain of the question in the writing. And also for philosophers, they will care about the ambiguous alignment. For example, shall we sacrifice 1 to save 5? So it is maybe both answer is correct, but they have their own opinion on this world. So it is also very hard to judge. So LLM needs the reasoning process to judge these harder problems, and also for to think about the thinking time. We also need to spend a long time to think about how to judge those harder problems, and we need the ability of long-chain reasoning, verification, subco-getting, reflection, etc. And also we need the LLM to have the ability to know those criteria on judge, and this is not given by a human. It need to think by himself through training. So it is the rough analogy of answering does LLM judge need reasoning. We all know that for thanks to the development of the LLM, so the LLM judge is still his knowledge is bounded by the LLM development, and for those harder judges, it also the judges can do more harder problems. And so this is the first question for our paper, and also our motivation is to stimulate the long-chain reasoning process of LLM judges. So we did this paper, JudgeLRM, large reasoning model as a judge, and it reaches Hugging Face top 2 papers of the day. And we can you can use the Hugging Face both models and spaces and GitHub, and I share to this paper page. So at first, I did some preliminary studies on do judges need reasoning. So it is the first question on why we should do this paper. So we can take a look like in the literature review for those previous SOTA judges, like in the Panda LLM and the JudgeLRM. they just requires the supervised fine-tuning, and they need a lot of detailed responses and explanations to learn a specific small judge, for example, like 7 billion judge. So this process needs a lot of human labeling. It needs the explanations, and so we want to think about SFT method is great, and can hit scaling, or is it a good way for LLM as a judge? So we first do an experiment on the gain in judge in the SFT versus the proportion of the source data set of the reasoning intensive samples. When we labeling all the data set, is it reasoning intensive from 1 to 10 for LLM? And finally, we found that, like in this paper, in this graph, the y-axis is the performance improvement from the SFT to basis, and the x-axis is the proportion required reasoning to judge. And we found that a negative or inverse relationship between the improvement of the F1 score from the SFT to base and on the proportion of the required reasoning. So we can reach the conclusions that the SFT struggles more on the categories demanding those higher reasoning depths, or those harder problems in the judge domain. So let me think about a new way to train or to stimulate LLM to be a judge. We can think about the reinforcement learning, because it is a traditional way to let LLM have the reasoning ability. And at first, I want to share about the DeepSeek. They use the method called GRPO, which is Group Relative Processing Optimization. It generates samples by normalizing intergroup advantages. So it's different from like PPO, DPO, and those previous methods. And it makes the DeepSeek success. And it reduces the variance and improve the stability in the strategy updates. And also because it replaced the value model in the PPO, so it reduces the training resources. And also the intergroup advantages let the query type bias reduced, and it can ensure the balanced performance. And I will introduce later this part. So let me think about the GRPO difference from the PPO and SFT training process on the judges. And we can find that the GRPO can adapt the strategy of optimization from the different groups. For example, for those harder judge problems, they will get like lower reward. For example, like 1, 1.5, or 2. And for those easy judges, like easier domain, they can get a really higher reward, like 7 to 8. So the previous part, like PPO, they were more biased to those easier problems. But for GRPO, because of the group-based rewards, it can alleviate the training imbalance to those easier tasks. And so it can make the task difficulties across domains. Well, if we can alleviate this imbalance to this. And also for GRPO, its learning is from the structural and contents rewards we define, and it can avoid pursuing absolute high rewards. So in this paper, we stimulate reasoning on judges, and we apply this method GRPO to learn judge data by defining the outcome-driven rewards. And we learn from the same base from the JudgeLRM and the CanLLM paper from the Q1 instruct, because it is a fair comparison between the baseline. And in our training process, it doesn't require any reasoning details. Like for example, in this photo, we can see the response includes the deep thinking process, for example, like hesitate, explore. But in our data, we don't need to include those thinking process. We just need to give him the two score of the judge. For example, the first one score is 1, the second score is 7. And this is enough for GRPO to learn judge data. And our data set includes those pairwise answer score from 1 to 10. And the data set is from the JudgeLRM and PandaRM. Mainly we train on the JudgeLRM data set. And it builds a source of rewards, it differs from score. And also it includes pairwise evaluation on those criteria. And we define the outcome-driven rewards from 2 parts. The first one is the structural reward, and the second one is the content reward. And the structural reward makes sure the answer is the first, he will give the thinking process, and the second will give 2 fair score from 1 to 10, including the in the answer in this quote. And in the context reward, it includes 3 parts. The first one, it should make sure the correct partial order of the judge. Like if the first answer is greater than the second answer, so we should make sure the first reward is higher than the second reward. And also for the judge-wise absolute reward, we should make sure the accurate score is good. For example, if the first one is greater than the second one, it's just greater than like the first one is the first one score is 1, the second score is 9, right? So if we give him like the first one score is 6, the second one score is 7, it is not a good absolute score. So we will make the reward low. And also for the confidence, we should make sure the LLM it reaches the great confidence of his answer. So I will let the like the answer from like if the first one score is 6, the second one score is 7. I will encourage the LLM to make the interval higher to give him the higher confidence. So this is the 3 part of the context reward. So this is our methodology, and so we need to ask about to answer the question on can we rely on reinforcement learning more than SFT, since the learning project is only from the 2 scores. So we did those experiments, and say both learn from the Q1 2.5 7 billion parameter and 7 billion, and we found that the reinforcement learning methods significantly surpass the SFT from 8 points in PandaLM in F1 and a lot of points in JudgeLRM. And in the JudgeLRM 3 billion, it surpassed the performance of GPT-4, and the 7 billion parameters surpassed the DeepSeek R1 by about 2%. So the JudgeLRM success on the deployable sides, because like the DeepSeek R1 and GPT-4 TSA parameter is really huge, and we can make it success to compared by those models, large models in 7 billion, and it can reach above 75 F1 score or higher. So you can deploy it in your own computer to be a judge. And also we can find that the reinforcement learning methods significantly surpass the SFT in different domains. And like the above line is the IL score, and the below line is the SFT score. So you can see it significantly surpass the SFT. And here is some further analysis. So we want to find the source of the JudgeLRM F1 gain. So we compare the correlation between the performance improvement from the IL to SFT, and also the performance on the reasoning needed instances. And we found a clearly positive correlation from the performance from the LLM to SFT. And the x-axis is the proportion required reasoning to judge. So it can gives the evidence for the reasoning intensive nature of the judge tasks. And also it gives the evidence for the effectiveness of the reinforcement learning than the previous SFT methods to enhance the judgment abilities through reasoning. And also here is an analysis to incentivize lengthy responses. So we want to push the boundaries of the LLM models. So it is a traditional way for the GRPO methods to be good. But we found that when we incentivize the slightly longer answers, it degrades the results. So about like 3%. So we think the merely increasing the output length does not benefit the judge task because of the repetition. So it is definitely longer, but it doesn't include the newer information in the incentivized answers. And here is a case study of our models, and we choose really hard problems in JudgeLRM, and here is the questions that he need to judge 2 answers of the history of the USA, and like it is the whole thinking process. And we found that in the JudgeLRM 7 billion, it includes the verification, sub-goal getting, and reflection, error identification, and like decision justification. And those thinking ability we doesn't provided in the training process. So the reasoning behavior emerges when we're learning from the reinforcement learning in a 7 billion parameter. So it is a success. It makes the success of JudgeLRM. And here is our demo. And you can compare you can choose any of the Hugging Face models, open models, to ask any questions to compare which one is better. And you can feel free to use the demo and find our paper and the GitHub. And here is the link, and here is a demo of the JudgeLRM. So here is our conclusion. The first we find the takeaway is that the judge is the reasoning intensive tasks, but the SFT struggles to answer that. And we raise the patterns of the LLM as a judge. It is a paradigm shift from that previous LLM as a judge. And we apply the JudgeLRM reinforcement learning to stimulate the judge reasoning. And we made the small model JudgeLRM 7 billion and it surpassed the DeepSeek R1 on the judge problems. And we finally get the takeaways that the successful judgment involves the complex reasoning behaviors. And here is some further analysis of this topic and this paper. And this paper we conduct the judge bias in the large reasoning models, and we found that the LLMs just remain susceptible to all detected bias. So it is the LLM is maybe greater than LLM, but it also will have the judging bias. And here is another problem in my own domain is the judging the scientific paper revision, like because it is a really open domain problem and a really long problem and a context-based problem. So it is a really hard job for LLM judge to solve. So in this paper, we introduced an LLM for the academic paper revision, and we spent so much money on the LLM as a judge because for the paper level judges, the context may be longer than 10,000 words. So we spend too much money on this paper. So it is another motivation of our JudgeLRM paper because the JudgeLRM can cut the money of the LLM, and we can make it deployable in our devices to do a judge, and the judge result is better than DeepSeek R1. And also this is the paradigm shift from LLM as a judge from the LLM as a judge. I wanted the society I hope the society can use more on LLM as a judge, because the current LLM as a judge paper we use it on different domains, like in medical, or like in finance, or like in academic paper revision. We need to use the GPT-4o or GPT-4 Turbo or even higher level GPT to be the judge, because a stronger judge can be LLM judge. A stronger LLM can be a judge. But for LLM as a judge, we can find that the 7 billion model is okay, and we can even batch evaluate in our own device to these judges. So I think it is better for the future LLM as a judge domain. And here is the reference. And thank you very much.